developed in Jupyter Notebook to detect the breast cancer in women. So let's start. So first go to the start menu and search for any kind of prompt and enter the any kind of prompt and type Jupyter Notebook to enter the Jupyter Notebook. So it can take some time sometimes. So this is the home page of Jupyter Notebook. Once you enter the Jupyter Notebook, just search for the file which you have created and click on that file. So this is the main prototype which I have developed to detect the breast cancer in women. So so first I have imported all the important libraries, to run the model such as Pandas, Keras, and Seaborn, etc. So let's run it. So after importing all the libraries, we have loaded the data from the PC. So the variable name given to the file was data frame. So after loading the data from the PC, we have summarized the data set by using this command dataframe.describe. So this is the output of the summarized data set. So after that, we have printed first 5 rows of a data set by using this command, data frame to the head. So let's run it. So it ran successfully. So next we have printed all the total number of rows and columns of our data set by using this command, data frame to save. So as you can see, there are 569 rows and 30 columns in our data set. So next we have to count all the number of columns with the missing values. So let's run it. So this is the output of the command, and we can see the total number of columns with the missing values. After that, we have to drop that column with the missing values by using this command. So let's run it, and it ran successfully. So as you can clearly see, the total number of columns was 33, where uh, the column with the missing value was also included. Now we have dropped that column. Now the new number of column is 32. So after that, we have take the proportion of people with breast cancer and without the breast cancer by using this command. So let's run it. So as you can see, the people with the breast cancer was 212 and people without breast cancer was 357. So next, we have to visualize this data in the form of count plot. So by using this command, we visualize in the form of count plot. So let's run it. So as you can see, this is the count plot. So after that, we have included malignant or the people with breast cancer and benign, the people without the breast cancer in the form of 1 and 0 to have a smooth operation of the model. So let's run it. And after that, we have plotted the data in the histogram. So let's run it. It can take some time. So this is the output of the histogram. It looks elegant. So next, we have also plotted the data in the pair plot by using this command. So let's run it. So as you can see, this is the output of the pair plot, which looks elegant as well. So next uh, we have got the correlation by using this command. So let's run this. So this is the output of this command. So after that, we have visualized the correlation in the form of heat map with the correlation number. So let's run it. As you can see, this is the output of the visualization of correlation in the heat map form. All right. So after that, we have split the data into independent dataset and dependent dataset. So basically, independent datasets consists two to measure components feature matrix, which is x in our case, and y, which is the target. So after that, we have split the data into training and testing set, 80% for training and 20% for testing. So after splitting the data, we have feature scaled the data by using this command. So let's run it as well. After that, we have checked whether the data has been scaled or not. So let's run it, and we got the successful output. The all the data had been normalized or feature scaled. So after that, we have started the process of building the model and training the model. So at first, we have created the type-based model by using this command. We have trained the model by using this command, and we have you know we got the prediction by using this command as well, and the result was uh, result was printed in the form of classification report, which is this. All right. So similarly, we have created the support vector classifier model as well by using this command. We also created a Canyon model. Similarly, this is a tree model, random forest model, and logistic regression model. So, uh, so this is the process to train the model, and these are the result with the metrics. All right, we can also test our model with the ISO accuracy in the testing data using confusion metrics like this as well, but this is the hard way. So we have created the confusion matrix, and we can do either this way, or we can print it in the classification report. Uh, Both are the same. So next we have predicted by the use of logistic regression model, because the accuracy rate accuracy rate of the logistic regression model was the highest among all the other models. So we predicted by using the regression model. So as you can see, this is the predicted data by the regression model, whereas this was the original data. So as you can see, uh, only some of the changes. Okay, almost every prediction was accurate, but there were some data with the different value. Such as you can clearly see here, we we can see the value 0, whereas the predicted data, as you can see here, the original data says person has not the cancer, but the prediction says the person has the cancer. So we have printed all the data. We also checked the prediction individually. So this is the command. So after running this command, we can see the output. The output says the person has cancer. So either way, we can check the prediction. Overall, the model gave the accurate results. So you can say the process of making prototype was successful. Thank you.